Welcome to everybody. I hope you are doing well. And today lecture is about lecture 8, that is all about flexible antennas. Okay, I hope others will join fast. I am waiting for the others people. There are very less people has joined today. Okay, I want to discuss a few things with you. Okay, let me share my screen. Okay, my screen is visible to everyone.
Yes, it's visible.
Okay.
Visible.
Okay.
Hello, sir. I saw your paper have been published. Congratulations.
Yes, thank you.
Congratulations, sir.
This is not only one. There are 3 other journals accepted, and I hope they will be published very soon. Okay, let's come to the main point. Okay, I have realized that the task I have given to you, very less people did the task, and that's why I want to change my schedule, so that we will have more time for writing. Okay, so for this slide I want to change my schedule like this. Wait a minute. Okay, so this was the schedule, and we have finished our first lecture, second lecture, third lecture, fourth, fifth, sixth, seventh. Okay, we have completed our 7 days. Okay, what we have next, today we will discuss flexible antennas. Okay, and for the others I want to change the schedule like this. I want to uh, remove this one, individual task. I want to remove this one, this I mean all individual tasks will be at the end of this lecture. I want to if I first target only antennas. Okay, I will
Yes, that's great idea.
yes, I will update the schedule. I will update the schedule and I will send you in the group. I am thinking that because I have given the task and very less people did the task, and what if I continuously give the lectures, like on the next day I will give lecture on human body antenna, then implantable, then that electric, and once we complete all the types of the antenna, then you will have enough knowledge to then you can decide which design you wanna work on. Okay, and then once you decided, then we will make groups of people, like 2 people want to work on the same topic, and you all of you have to publish one conference and one journal. Okay, so for that I want we convert all these individual tasks on the next 15 days. Okay, last 15 days or 10 or last 10 days. Okay, so that we will have enough time, so that we can discuss everything, like on daily basis we will writing research papers. Okay, and in this short period we can easily complete the research paper. Okay, in these 15 days we can complete a conference paper and a half journal. Okay, in this way I hope all of you are agree with me. What do you say about it?
This is a very good idea, brother Sarosh. Yes, amazing idea. Yeah, that's fine. That's fine. That's very good.
Yes.
Because actually sometimes we are busy to maybe to make a task for everything in there, because sometimes our specialty is different.
Yes, because on the working days I have classes from 2 p.m. to 8 p.m. according to Spanish time. That's why I suggest you this time. And for the Friday, Saturday, and Sunday, I don't have any problem. Maybe we can have a lecture on 4 p.m. Okay.
For Friday, Saturday, Sunday, yes.
Friday, Saturday, Sunday, if you agree, all of you. But
Saturday and Sunday maybe at 3 p.m. is good.
Yeah.
So for me actually, I missed maybe 4 to 5 lectures. The fact is that I cannot actually maintain this schedule due to my busy schedule in my university. So it would be better if you continue all of those classes, whatever the Spanish time 3 p.m. or 4 p.m. is going to be very helpful for me also, if possible. If not, then it's gonna be okay for me.
For the working days, as I told you, we will follow this timetable 12 p.m. and for the weekend like Saturday, Sunday, and Saturday, I mean Friday, Saturday, Sunday, 3 days, we can have classes at 4 p.m. Okay, or 3 p.m.
Okay. Okay, thank you. Excuse me, Ahmad. The current one, the 12 p.m. is. I think it will be okay because we have to lot of appointment in a Saturday and a Sunday. So that's why, and we schedule for 1 month. So that's why, if we change it again, so it will be a little bit difficult because we also talk with supervisor that I have a course to complete for the whole month. So he gives us the slots.
Okay, only Friday at 4 p.m. is okay for all of you. 4 p.m.
Yes.
And for the other days the same timing. Okay, 12 p.m. Okay. So what we have decided, I will continuously give the lectures.
Sorry, Mr. Ahmed. Can you please focus on the research paper?
Yes, that's why I am just telling you that I continuously complete the designs so that we will have enough knowledge and we can mix the fields, I mean mix the types of the antenna, and then we will in the, for example, if we have 15 or to 12 days for writing research paper, for the 2 to 3 days we will decide the design, how much should be, or we will prepare the design, okay, for to get some novel aspects, okay. Then on the next 10 days we can continuously work on the writing research paper, okay.
Yes, because we need more knowledge
Yes.
and tips about research paper.
Yes, that's why I've decided, because I individually I check that very less people are working, so that's why once I complete these topics, important topics, then we will focus on the research writing, okay, and I will surely guide you and help you in that regard.
Yes, thanks a lot.
Yes, and also, you know, yes.
It will be like in a collaboration with each other, something like that.
Not you all work like under my supervision in that case, okay, and suppose two people like to work on implantable antennas, then I will create a group like you and other people, other person, okay, and with me, okay, and suppose some people like to work on dielectric resonator antenna, only two people are allowed to work on this same topic, okay.
Yes, yes.
So you have to decide the topic once we have completed these topics, and then we will decide the research topics, the on which design you want to work on, and how you want to start, okay. Our main focus is only IEEE journals, okay. So that's for that case I like to if you work with me, and I will surely help you to target IEEE journals, okay. And suppose in some case, if somebody not able to write IEEE journal, then also there are so many other journals we can other also target other journals, and forget about the funding, I will provide it, okay, don't worry about it.
Thank you. But brother Ahmad, you talk about the IEEE journal, you mean axis or another type of transactions?
It can be other journal, but I mean IEEE means all other types of journals, okay. It can be IEEE access, it can be IEEE transaction, others, okay.
Actually, if you could publish in an antenna and propagation open access, or the letter will become very great because it takes almost 1 month.
Yes, no problem. We will decide later on, okay. You are open, I mean we are open to decide the journals, okay, later on. It depends on the work on the paper. If the paper quality is very good, then we will decide. I will suggest you the journal where we should target it, okay.
Okay, go ahead.
Okay. Okay, everybody agree with this schedule that I will continuously give lectures on the topics, and then we will have enough time to continuously work on the research writing skill. Because if we on the like one day reading and one day working is I think not a good idea, because very less people like to work in this way. Okay, and even cannot focus on even one design. Okay, that's why if we have enough knowledge, then we can decide which design we want to work on. Okay, suppose we can work on implantable, or we can work on like wideband and mix with the my antennas. Okay, as I you saw my paper recently published in AAA. Okay.
Yes, absolutely agree. I agree also.
Okay.
Okay, sir. Agree, sir. Thank you, sir.
Okay, good luck. Okay, so let's start with the flexible antennas. Okay, and I remove this one. Okay, so today lecture is about flexible antennas, in which we will study how can we analyze the flexibility of the antenna. And because actually there are three different ideas, these flexible antennas can be interlinked with the other types of the antenna, like for human body antennas, and it mostly used in human body antennas, like implantable flexible antennas. Okay, so we can mix flexible antennas with human body antennas. Okay, we can also mix flexible antenna with implantable antennas. Okay, because in flexible antenna we also have many different types, like wearable antenna, like textile antennas, because a cloth is a flexible material, and when we wear a cloth, and when we sit or sit down, and when we stand up, and when we bend our hand, our cloth bend a lot. So that's why flexible antennas have a major and a very important role. Okay, so we can mix this flexible antenna in many other types of the antenna. Okay, so in this way we will have good designs. Okay, like I want to first we will study some review on flexible antennas, that which type of flexible antennas are available in the research, and I will show you some one of my designs. Okay, also we can focus circularly polarized implantable or circularly polarized flexible antenna. Okay, so this is the flexible circularly polarized antenna, because circularly polarized is very in terms of novel aspect, we can have circular polarization. Okay, if we achieve circular polarization in flexible or in all types of the antenna, like in wideband or in flexible human body dielectric, in each case if we achieve circular polarization, it is one of the novelty. Okay, so it is very important thing.
Sorry, Mr. Ahmed.
Yes.
Can you please give us a short introduction about what you mean by flexible antennas?
Yes, I am just starting. I am just giving you some ideas that how and where we can use flexible antennas. Okay, and then we will learn how about bending analysis. And okay, so in this case, flexible antennas, it is a review paper. Okay, and we will study some and we will see some diagrams of the flexible antennas. Okay, and we must need to know which flexible materials are available in fabrication and in real practical use. Okay, okay, let's discuss it. You can see there are different types of flexible antennas here. Also, nowadays it is a very hot topic on embed the flexible antenna on a smartwatch. Okay, and for IoT application, I have one journal on this smartwatch. Okay, I will send you in the group. Okay, and you can see here there are a lot of flexible antennas. The most important thing, which type of flexible material they are using. Okay, and how much they are flexible. Some materials are flexible along x-axis, some materials are able to bend along y-axis. Okay, so we also need to check this thing. Okay. Okay, suppose you can see here this is actually an invisible substrate. Okay, and there is the name of this substrate is this is one. Okay, polystyrene. Okay, but this material I think not available in my lab, or if it we can order this material, but I suggest you to use polymer substrate or PDMS substrate, this one PDMS. Okay, you can find I think in the CST you will find if you write the PDMS you will find a material, okay, and you see this is actually a flexible material, okay, and that can be bent along x-axis or y-axis, okay. And we will also discuss and study how can we bend and analyze the bending analysis of the antenna, okay. So there are many types of material, okay. You can see this is an invisible substrate, okay, like a transparent paper, okay, or transparent sheet. And also some flexible are made of textile material or cloth, okay. I will show you here. Yes, you can see I think this is a cloth. This is made of cloth. It can be of cotton material, okay, it can be of jeans material, okay. I made one design on a jeans material, okay, so you can use a jeans material, okay. I will whenever you decide a material you need to know the properties of that material, okay, like relative permittivity, low stringent and thickness available, okay. And you know also in some glasses we use antennas, this is of transparent antennas, okay, very small antenna, okay, to record and it is embedded with some sensors, okay. There are a lot of applications of flexible antennas, okay. But we do not go to very complex one. We will focus only that application that is easily fabricatable here, and we will not have any problem, okay. Okay, so you can see this is of I think this is a jeans material, okay. Let's check the material here. They did not, I think, mention the substrate material, okay. Yes, you can see here this is I think another cloth material, textile. In textile antennas, yes, one of my friend from I think from Algeria or I think from Egypt, he has a fabrication facility of textile materials, okay. So I can ask to him to provide us the data sheet that he has in his lab for the materials, like for jeans material, and we can work on also on visible antennas, and they are flexible materials, okay. And some people like to make a flexible antennas and with meta material, okay. One of my paper is meta material based flexible antennas, okay. And in Rogers, if you are using a very less thickness substrate, like if you are using less than 1 millimeter thickness, like 0.76 millimeter or 0.25 millimeter substrate material, then it is flexible in real time, okay. But in prototype, if you are using 1.6 mm or 3.2 mm, they are not flexible, okay. In simulation yes, but in experimental they are not flexible, okay. I will provide you the data sheet of the flexible materials that we have in our lab, okay, and then you can work on it. But I first suggest you to use you can use Roger material that has very less thickness, okay. And some people use flexible antennas in implantable antennas, like you are using a flexible material of polyamide, and you can rotate or turn the or blend the flexible antenna on a capsule, okay. So it will, in this way it will become a capsule endoscopy implantable antenna, okay, implantable flexible antenna, okay. Like you can see here, this is a flex antenna made of flexible material. Here they did not mention the name of the material, but I think this is a polyamide substrate, okay. And sorry, it can be Roger ultralum or it can be polyamide substrate, okay. And they have blended the antenna on a capsule, okay. And then they have inserted the antenna in a phantom, okay. It can be a skin mimicking gel, or it can be another material that has the property of the muscle. Okay, and also you can see here they have uh, there three they have what we say, I forgot the name. In this, like they have a battery. Okay, in a capsule, they have inserted an antenna. Okay, they roll the antenna. Okay, they have rolled the antenna in I forgot the name, but and connect this antenna with battery, and this is a capsule. Okay, and then they have embedded into inside a minced pork that has the same properties of like a muscle tissue. Okay, that has the relative permittivity of 58, near to 58. Okay, or 54.
Excuse me, Mr. Sarosh, it's endocapsulate. I think
Yes,
endocapsule.
yes, this is an endoscopy.
Yes.
Yes, endoscopic or capsule antenna. Okay, in implantable they are very same. Okay, you just need to blend your antenna on a capsule. Okay, and then you can test in the minced pork or skin mimicking gel. Okay. Why the it is important to have a flexible antennas. Okay, suppose what is the characteristics of these flexible antennas? Suppose you have design an antenna. Okay, suppose you have a x-axis, okay, and y-axis. Okay, you have S11 on x-axis and frequency on the, oh sorry, S11 on the y-axis and frequency on the x-axis. Then suppose you have operated the design at 2.45 gigahertz. Okay, and your design is operating at 2.45 gigahertz. Okay, minus 10 dB. Okay, suppose if you in flexible antenna you need to achieve some more bandwidth, so that if you bend the antenna suppose along x-axis, then because if you bend the antenna your S11 may shift. Okay, so if you have a wide band, maybe like you have bended the antenna along x-axis, and it will behave like this. Okay, so if you have a wide bandwidth, then it should cover the ISM band. Okay, like this one, 2.45. Okay, so when you bend the antenna, it there is a little shift in the frequency. Okay, if there is a no change in the frequency band, then you can say your antenna is a flexible antenna. Okay, and suppose after bending your antenna you are not able to achieve the same frequency band, then you cannot claim that your antenna is a flexible antenna. Okay, so you bend you check the antenna in both axes, in along x-axis and along y-axis. Okay, to check whether the bending the antenna is bendable or not. Okay, like this one. Okay, this is my another journal. This is a Q1 journal of Tech Science Press. Okay, it has an impact factor of 3.772. Okay, okay, we will discuss about the flexible circularly polarized antenna. Okay, we are not discussing implantable antenna. Okay, this paper is 70% on flexible antenna. Okay, so we will discuss in detail this antenna. Okay, you can see here this is a very simple antenna made of a Roger 5880 substrate that has a thickness of 0.25 millimeter. Okay, and I also suggest you to use this material to make your antenna flexible, because Roger 5880 is a compatible substrate, and also it is a bendable substrate. It will not disturb your frequency. Okay, if you bend your antenna, okay, along x-axis or y-axis. So you can see this is a radiator that has some slots inside, and this is a field line, and this is a modified ground plane. Okay, this is a CPW ground plane. I have you can see I have modified some shape, and also this one to achieve the circular polarization. Okay, the size of the antenna is very small. Okay, in implantable antennas, now people are working on implantable antenna. The implantable antenna has a size of 7 cross 7 millimeter square at the frequency of 900 megahertz. Okay, and also I have some papers, published paper on implantable antenna that has size of 5 cross 5 millimeter square. Okay, at the frequency of 900 megahertz. Okay, So this design has a size of length 21 millimeter, okay, and the width is 13 millimeter, okay, and it is operating at 2.45 gigahertz, okay. So this is the design steps of this antenna. First I designed a simple patch antenna, okay, then modified the patch radiator, okay, and then modified the CPW, and then created a slot to achieve the wide bandwidth, okay. So let's discuss in its flexibility, okay. Okay, so in the simulation you can see, first I bend the antenna along x-axis, and you can see even if I bend the antenna at 20 millimeter, okay, radius, and I simulated it to from 20 millimeter to 100 millimeter radius, okay, and you can see the band still remain the same at 2.45 gigahertz, okay. So it is a flexible antenna, okay. You can see along x-axis it has the same results as it when it is not bended, okay, and also you can see the change in the axial ratio, okay. There is not much difference in the axial ratio. This is along x-axis, okay, and then I have tested this antenna in the lab. You can see you can use a foam material, okay. There is a white foam, you may know, that has properties like free space, okay, and you blend your antenna along x-axis, and the transparent you can blend this antenna on a foam and then connect with a sticker or tape, okay, and then you can see here it is yes, bended along x-axis, and the radius of this foam is 30 millimeter, okay. That's why I was able to test the antenna only at 30 millimeter, okay. Then simulated the antenna along y-axis. You can see here, first I simulated at 20 millimeter and then 100 millimeter, okay, up to 100 millimeter, okay, and you can see the S11 still remain the same, just with some little reduction in the return loss, but it is still below minus 10 dB, okay, and at the operating band of 2.45 gigahertz, okay, and there is no big change in the axial ratio, okay. And also I tested along y-axis, okay. You can create a circular form, okay, and then you can test your antenna along x-axis or y-axis, okay. This is the same form, but I just change the direction of the antenna, okay, to check bending analysis along y-axis, okay. And then we will study implantable antenna, then we will discuss these things, okay. Okay, in CST we simulate this one, this antenna, and check bending analysis, okay. But whenever you, yes.
Could you also this review paper and the other paper?
What?
Could you send us the review paper for the material and for this flexible antenna?
Yes.
And also your paper, if it is possible.
I will send you. I cannot send you this paper because actually this is accepted, and I hope in few days it will be published. When it is published, then I will send you. Okay.
I'm sorry, it's not published yet. At least this review paper, at least. Yeah.
Yes, I will send you this review paper, and also I will send you the data sheet of the flexible material that we have in our lab. Okay, that you can use. Okay.
Please, thank you.
Okay, the other thing, if you want to work on the flexible antenna, then must combine use complete application like implantable flexible antenna or human body flexible antennas, okay, because we need flexible antenna only most widely used in these cases, okay, human body antennas or implantable antennas, okay.
And I think also you can use it as for MIMO antenna for the glass of the car or something like this, or the mirror of the car.
Yes, but in MIMO I did not see many paper on flexible MIMO antenna, because in MIMO antenna most people like to work on the novelty of to reducing the transmission and many other things. Okay, like to achieve better achieve
Isolation, yes,
ECC.
isolation and maybe to enhance the performance, I think, the diversity performance also like this.
Yes, but we do not use much in flex in MIMO antennas. Okay, we even we can use in antenna
In
array.
case of MIMO antenna, brother Ahmed, about the phantom itself in CCD, I think for free CCD we cannot find this phantom.
Don't worry, I will provide you everything. Okay, even if you don't have in CST, then I will provide you extra. Okay, then you can simulate in your own CST. Okay.
Thank you, thank you.
I will provide you each and everything what you need. Okay, the most important thing when you are simulating this human body antenna or implantable antenna, then I will provide you human phantoms and what you need. Okay, because in the correct CST variant you don't have these materials. Okay, so I will when tomorrow we will discuss in brief detail. Okay, human body antenna, and I will send you some files that you can import in your CST. Okay, even I can send you the human hand. Okay, on which you for the application of smartwatch application. Okay, and you can use in your CST, or you just need to import into CST, and I will tell you some steps that you can follow, and you can easily simulate. Okay, in your CST.
And the head, Mr. Ahmed also.
Yes, I will provide you. Okay, don't worry.
Thank you.
Because there is a complete human body model, and you can import or you can cut whatever you need. Like if you need hand, you just need to crop your human body model, and you can use the hand material. If you need head, then you crop the whole body and just keep the head of the human body. Okay. So tomorrow it is very interesting lecture on human body antennas, and also on the next day we will discuss implantable antennas. Okay, and I will suggest you at which frequency you need to work on these type of antennas. Okay. There is a question. Yes, I will send you the spotting documents through email. Don't worry. Okay. What will be the maximum frequency range to work with flexible antenna? Which one is the good substrate material which is easily available? I told you, Roger, 5880 is easily available everywhere, because it is a flexible material of thickness 0.25 millimeter or 0.508 millimeter. Okay, you can use that material for the flexible antenna. Okay, don't use FR4, that is not a flexible material if you are using a 1.6 millimeter, okay, thickness of FR4. But if you are using 0.8 millimeter thickness of the FR4, then it is somewhat flexible but not fully flexible. Okay. The main target is to complete a design. Okay, and then to target a research journal. Okay, so we will complete these topics day by day. I hope in 10 days we will cover our topics, and then we will start. I will give you a brief introduction and brief detail on the professional graph tools. Okay, so that you are also you are able to make a good resolution graphs. Okay, because in journals and in research papers, mostly we will reject the paper because of low quality graphs. Okay, so we will also discuss in detail. Okay, and I will provide you the links from where you can download these softwares. Okay. Okay, so there's some flexible materials. Okay, all rods are flexible if you are using with less thickness. Okay, I use this material for flexibility, and also I use this material for flexibility. Okay, and this is available in our lab and with every thickness. Okay, also this material is available 6002 of thickness 0.0 0.76 millimeter. Okay.
And Ahmed, what the others substrates?
I will write. I will send you
I mean,
that.
in CST, I mean in CST.
Yes, there are so many materials. Okay. It depends on the application where you are using. Like if you want to use your antenna in underwater communication, then you create a box of water of this one, okay, or this one, and you can simulate and check whether your frequency is stable at the desired frequency band or not. Okay, if it is stable, then you will calculate some more parameters, and then you can say you can utilize your antenna for underwater communication.
Excuse me, Brother Sarush, you mean I can make the free space around the antenna is water?
Yes, I mean, like in this radiation boundary, in this box, like let me create a substrate here so that I can discuss here.
Yes. So you mean that you change the background?
Wait a minute, wait.
The radiation box.
Yes, this one. Okay, suppose you have your antenna, okay, and you need to create a box like this, like you have your antenna like this, and you need to create a box, okay, or you there are different ways, okay, like because your antenna is will be in water, so you can even change your free space into water, okay.
And the water property is available here, yeah?
If you want, you can I think you can apply here dimensions, okay.
Yeah. The dimension at this time has a specific size, or I can make any dimension, because I think at least it become lambda over 2, I think.
No. Actually, you need to write the research. You need to check the research paper. Okay, which like some. It depends on the size of your design. Okay, or there are some websites where you can go and write the properties and size of your antenna, and then they will suggest you the size of your like of water cylinder or water box and many other things. Okay.
Because actually I have a data about the oil, and now I'm working in the sensor. But my problem, I don't know how I can create the oil around the sensor, the antenna sensor.
You can create a bond. You can create a brick. You can write here like air, okay, and you can create a boundary here like of 100 millimeter, okay, 100 millimeter length, 100 millimeter. Like it depends on the size of your antenna, okay. If your antenna is very small, so you can set it according to it, okay, because the properties are the same even if you are increase or decrease the size, but keep it more than 50, not less than, okay. And because you know even you have, if you have water in much quantity, then the properties will remain the same, okay, it will not change. So in this way it will not affect much, okay. So in this way you can load the material like air or water, okay, like this one, okay. So in this way you can use this one, okay,
as a reference, yeah.
yes, okay.
Thank you.
Okay, so the next what is the dimension? This is 15 cross, and you see the size of the antenna is very small, okay. This is 21 cross 13 millimeter, okay. Why the size of your antenna, even if you are designing the antenna for implantable, thus design the size of the antenna is still very large, okay. Because for the implantable, researchers are doing work to reduce the size of the antenna, okay. Mostly are working on 5 cross 5 millimeter or 7 cross, okay. 7, many research has been done on 7 cross 7, but now they are working on 5 cross 5 millimeter square, okay. Even I have published paper on this 5 cross 5 millimeter square, okay. Okay, for flexible antenna, you see the thickness of the substrate, okay. The thickness is very you can even say this is a low profile, okay, antenna, okay, that has very thin profile of your antenna. Okay, so now there are so many ways to design the flexible antenna. This is a designing is the most important thing. Okay, if you know designing, you can even implement the design in your each type of your antenna. Okay, you can make any shape. As I told you, in antennas you are open to work, but it depends on your results. If you have achieved more better results, then surely you can defend your paper. Okay, and also you can use this curve like an outline. Okay, suppose I have an idea in my mind and I can start designing, okay, with this tool. Okay, whatever I have in my mind, like I am thinking that I should try this shape. Okay, what will happen if I make this shape like this one? Even you are not restricted to make the CPW as same as I told you. You can even modify the shape of the CPW, or you can use CPW in many different ways. Okay, like I am going to use here. And also it is not necessary that you make the strip line at the center of this design. Even I have some designs, I will show you, but the paper is not published yet.
Yes.
That
you
one
can shift the feed line.
Yes, in one of my design, the journal, in scientific report journal, I designed the antenna. Okay. Do you know scientific report by nature? This is a Q1 journal, and it has an impact factor of 4.22. Okay.
Yes, yes. Yes, I have maybe four or five publications in it.
Yes, it is very good journal and very famous journal.
Yeah.
And
it is very, very expensive.
Yes, and you can see here I did not I even modified the shape of the design, and I also did not use the field line at the center of the substrate. Okay, I use because if you use field line at some distance from the center, then it is help you to increase get the circular polarization. Okay, you can see if the current will flow in this upward direction, and then in this way your current struck with this strip line, with this load and this load and this load and this load. Okay, and it will give you some circular pattern. Okay, also like this one. Okay, with this you can see here. Okay, and this is very good design. Okay, and inshallah it will be published very soon. Okay. I have a lot of design, but they are not. Some are published and some are not yet. That's why I'm not showing you all of my design, but I'm giving you some ideas on which you can work on it. Okay. You can see I am just creating an outline whatever I have in my mind, and I will check how will be the results. For the patch you need to use copper. Okay, this is ground. I am using this as a ground. Okay, like for the CPW, just with a modified shape. Okay, and I am going to create a shape for the radiator. After that you can again modify the shape by creating slots and many other things. Okay, and in this way it is easy to achieve. If you modify or make any shape, then you can easily get the circular polarization. Okay, if you can see some of slots are at an angle of 45 degree, so in this way you can easily achieve circular polarization. Later on you can even cut this shape. Okay, you can change your shape. Okay, I am just designing okay, whatever I have in mind. But in order to design in order to proper design, then you need to you can make a figure on your copy or your on a paper, and then decide which type of shape should I design. Okay, and then you need to work on it. Okay, you need to work a lot, you need to optimize the slot, you need to optimize the field line, length of the field line, width of the field line, and then width and length of the patch, and many things. Okay, so in one day you are not easily design a simple antenna. Okay, I mean, to achieve good results you need to work a lot to achieve much better results. Even for my own designs, first I spent more than 2 weeks. Okay, maybe 2 weeks, maybe 3 weeks to achieve more better results, if when I did not have any experience in designing. Okay, but now I have experience, so even I can suggest you more important things. Okay, to achieve more better results.
Brother Sabuji, actually, I want to ask you something. When you selecting the size of the substrate, you selected according to the equation of in EM box. When we just I said, okay, I need to make antenna, for example, 1 centimeter by 1 centimeter. After that, I seeking in the design because we have also a limitation.
At first I told you in the previous lecture, you only design I mean you only use equations for this simple patch antenna. Okay, but for for the designed antenna you do not use equations. Okay,
yes, sure.
Yes, and you just check these equations and calculate the size of this substrate. But it is even as I told you, if you study the research, even you can see in the yes, in this table, some are, you can see all are same frequency. Okay, but why the size is different? Okay, why their size is different from this one? Okay, so it means they are not following any equations. Okay, so just people are doing work to reduce the size more and more.
Ahmed, so it's mean that we don't have to follow the equation, something like that, for the final design.
Even if you study the research paper, you will find equations in the research paper. Okay, but they do not follow the equations, they just add to show that we are following the equation, but even in fact they did not follow any equations.
Like for the irregular shape, like the turnstile antenna, something like a dipole, we put some upper element on the top and the lower side, so we don't have to follow any equation for that one.
You can follow. Even I'm not saying that you no need to follow any equation. Some people like to go with the equations, okay, to make a proper design, okay. But these type of equations are mostly usable or suggestible in simple patch antennas or simple circular patch antennas like this, okay. But if you are creating different shapes with the equation, you can just know the size of the substrate, okay, not with the radiator, okay. You can know the size of the substrate, but in patch or in radiator, in ground plane, you are open to make any type of shape, okay. Because even the shape will not disturb you the size of the substrate, okay.
And one thing is more, in a CST, we can also, if we want to optimize the parameters, which we define it by the practical sum optimization algorithm and something like a differential evaluation algorithm. So is it necessary to parameterize all the parameters of antenna?
Yes, it helps you a lot to achieve more better results, okay. Like why I keep this size of the patch, okay. If you go to the in the simulation, you will find parametric sweep option, okay. Then you can optimize or you can run the simulation for 4 times with different length of this patch, okay, of the radiator, okay. Then you will know if I increase the size of the radiator, then what will happen with my with the frequency of my antenna, okay. And in this way it is easy for you to optimize the design, okay. And then you can easily achieve better results, okay. And you will know why I'm using this load, what will happen with these loads on the operational frequency, okay.
Because nowadays the design are making an artificial intelligence, and we make some parameterize the antenna, and we use the SADA algorithm, and we have to optimize by AI algorithm.
Yes, in the simulation of the like of different softwares, like for if you are designing the antenna with Python or with artificial intelligence, then I cannot say anything, okay. Because this is a very new field that are shifting towards the antenna, okay. That's why I do not say and suggest you anything, because they are working from the beginning, and from the beginning you have to follow the equations. But when there is a lot of research will be done, then they do not follow any equation. But in the coding, you have to follow the equation. Without equations you cannot be able to make a code like this, okay.
Okay, thank you.
But here, this is a CST software, and we are not using coding, any type of coding, to design antennas, okay. Okay, so you can see here, okay. So you will see your antenna is shifting from the lower band, and also you need to increase the bandwidth of the antenna to check either which frequency it is working, okay. When you are unable to know at which frequency my antenna is resonating, then I suggest you to increase the frequency range, okay. And once you know, then you can again decrease the range of your frequency, okay. So dear Muhammad, do you have any other question?
Actually, brother, sorry, I asked you this question because to reduce the size of substrate, and also using 900 megahertz. I'm not confused, but how we can do it? Because if the frequency is reduced, the size of the antenna will become little bigger.
Yes, I told you. If yes, yes, complete your question first.
900 megahertz. This means the size of the antenna will become bigger.
Yes.
But if I made a resonate maybe around 10 gigahertz, surely it will be reduced little bit. We cannot say it will reduce
okay. Let me explain one more thing. Then you will say your concept is wrong now. Like if you are working on implantable antennas, okay, okay, that has a size of 5 cross 5 millimeter scale. The frequency should be more than 28 gigahertz, okay. But they are using 5 cross 5 millimeter scale to operate at 900 megahertz, okay. So where is the questions now?
Actually, I wonder. Maybe the material play a role in this.
No, the same material. Like if you want to use Roger 5880 for this and 5880 for this, the same size.
So this means working on the slots or something. Yeah, of course, it will play a role, the slot or modifying. But I mean the size of substrate itself.
Yes, actually, your antenna size just depends on the substrate size, not also on
Yes.
the radiator. But if you, as I told in the previous lectures, there is another. Some people like to calculate in electrical wavelength or guided
Yes,
wavelength of the
yes,
antenna.
yes.
It tells
There is
about the size of the radiator. Okay.
yeah, the size. Yes. In this case, we can know the trick now.
Yes.
It is a trick. Yes, thank you.
Wait a minute. There is a question in the chat box. When creating shapes is first recently Terahertz antenna design is considered as hot topic. Can you please manage a lecture on it? Yes, I will try to give a one lecture, or maybe of in some lectures I will discuss about terahertz topic. Okay, terahertz is not a very difficult one. Just the change in the frequency. Some people are just shifting towards the higher frequency bands, and there is a lot of limitations at terahertz. You cannot be use FR for substrate because of the the thickness is 1.6 millimeter. Even the size of the antenna at terahertz starts from the 1.1 or 1 millimeter. Okay, so people are just looking the materials and the thickness. What should they decide? Like for the terahertz, there are no people I think working on. I also have one paper on Tera, but it is not published yet. This is a simple antenna, uh, but not here. I think this is not here, but there was one paper on terahertz. I use I think India. I will send you the list of the materials that we can use at terahertz band. Okay, I think there is indium phosphate. Okay, some people work on this one. Okay, and I think it is available of 0.01 millimeter. Okay, thickness. And yes, I have one paper that is published in MDPI. Okay, so some people works whenever works at terahertz, they discuss one thing, photonics, and other things. Okay, and the substrate I think I have used here is
this one is polyimide. I think you can. Yeah, I studied this paper.
Yes, this is a
polyimide.
Polyimide substrate. Okay, and the thickness is 192 micrometer. Okay, so you can even use this because polyimide, as I told you, it is available with many thickness. Okay, it is also available 0.05 millimeter. Okay, and also 0.0 I think 2 millimeter. Okay, this material, but this paper is only based on the simulation only. Okay, not fabricated.
Yes, I read it. For that, I was astonished actually because we cannot fabricate it. I think.
Yes, this is not fabricated. Even my other papers on one my I have one other paper on Terahertz, but it was rejected from MDPI. They asked me why you did not add the measurements results. But in this paper, there are three types of antennas are discussed with this one. Like this is a square shape. Okay, and this is triangular shape, and this is circular. Okay.
The main thing is to insert the size is very small, so this is the main difficult because this I think you put the circle is 20 microns.
Yes, that's why I told you at Terahertz band there is a lot of limitations. Okay, so you need to discuss and get knowledge in brief detail, and then you can be able to work on Terahertz in case if you want to go towards the experimental results. Okay, another question: when creating shapes, is it advisable to start straight away or start with the basic antenna shape first, like rectangular or circle? Yes, I suggest you to first make a simple patch antenna, like if you want to make a microstrip patch, because in my papers you can see you can even see my each paper I just discuss with simple patch antenna like this one. Okay, I always start with the simple patch antenna. Okay, and then I will try to modify the shape. Okay, in my each paper you can see these type of design steps. Okay, in my each paper and in my each design I tried with a very simple one, like if I want to work on a circular patch, then I will start with the circular one and will try to modify some shape. Okay, and then I first you start with, I also suggest you to start with the simple patch and then create a very small or modify the shape and then again simulate. Okay, and check result what is the effect on the S11. I'm not saying that you first create a simple patch antenna and then create a desired antenna and even you don't know what is the change in the frequency. Okay, so you must know these steps. Okay, and you know what is the change in the frequency. Okay, and like this is your antenna 1 and you can see in antenna 1 your antenna is working at 2.7 gigahertz, and then in this step your antenna is working at 2.6. You can see my frequency is shifting towards the lower frequency. Okay, dear Ambrish, you can send me the picture of your warnings. Okay, because a warning does not affect your results, just they are just a warning, or maybe because of your system compatibility. Okay, okay, so for this antenna I like to uh, discuss about the flexibility, how to check flexibility. Even you can design at our frequency, any frequency. Okay, I am just sharing here flexible antenna. Okay, so this is your flexible material. Okay, and in simulation flexibility of any material is available. Okay, because even if you are using FR4 in simulation you can bend the antenna, but you must know which type or which material is experimentally bendable. Okay, and then you need to use that material, like this Roger material is experimentally bendable, so you can use this material. Okay, in simulation. Okay, okay, so first I do not suggest you to align your WCS in the front side of this substrate. Okay, I suggest you turn your antenna and use this align WCS on the other side of this substrate. Okay, and then check select all the components. Okay, and then go to the bend tools and check this click on this cylinder bend. Okay, and you need to select the both sided. Okay, okay, and click on the preview to check, and you can see here your antenna is now bending. Okay, this one. Okay, you can write here bx bending along x-axis. Okay, and click on the preview and write here 30 millimeter. Okay, or 20 millimeter. In the paper I have used the same thing. Okay, and click OK, and in this way you can run the simulation. Like you can go to the and you even don't need to do multi simulation as while as you design antenna and check your results and then again simulate. You don't need to do like this. Okay, if you know you are using Roger 5880, you need to run the simulation only for one time. Okay, first your finalize your antenna, like you finalize your antenna at 2.45 gigahertz, 2.45 gigahertz, and you know I have used the flexible material. Just run the simulation for one time. I suggest you to use parametric sweep. Okay, only one time. Okay, just you need to write here like 20 to 100. Okay, and use you need to use 3 or 4 samples. Okay, 4 5 samples. Yes, it will calculate at 20 millimeter, 40, 60, 80 and 100. Okay, and you need to run the simulation like this. Okay, and it will check your results, okay, at different radius. Okay, and then you will check either your results are operating at 2.45 gigahertz. Even if there is a little shift in the frequency, then no need to worry, but your band, I mean 2.45 gigahertz, must be below minus 10 dB. Okay.
But I think you need to stop the simulation or to make it one by one to take the snap for the antenna itself.
For sure, I will stop the simulation. I'm not going to wait for a long
Yes, yes.
time. I am just showing you how can you do parametric sweep and calculate the
This
bending.
is nice. That's
Okay.
actually very nice.
Okay, and also I will show you here how you blend your antenna on a smartwatch, like like if you want to blend this antenna on a smartwatch. Okay, first this is the way of your bending along x-axis. Okay, in the same way for the y-axis you need to just rotate your WCS first. Yes, no, just for the y-axis you just need to rotate your design, okay, at an angle of 40 sorry, rotate your WCS at an angle of 90 degree. Okay, and for the vertical axis you only need to bend along y-axis and you need to use one-sided. Okay, no need to use dual-sided, as I explained the reason before. Okay, by
Because of the connector issue.
yes, on the other side, if you bend from the other side, you will have a connector issue. Okay, it will not connect with the port. Okay, so in this way you can do simulation. Okay, and in the next lecture I will show you how to make graphs. Okay, because some people, you see in my paper I use these bending graphs. Okay, like this one. Okay.
Actually, I think origin to insert a picture in origin is very nice. I usually do it.
Yes, Origin is a very good software, and at first I was using Sigma Plot, but now it is my all softwares are expired because I did not use for a long time. Okay, so
Actually, my partner use it, but I don't prefer it.
yes, so in this way you can do this simulation. Okay, okay, so like even you, I have designed, I think, a smart watch, but I'm not going to show you, or maybe. In CST you can even design a smart watch, complete watch. Okay, and then you can blend your antenna. I think I have a CST file of this smart watch, and also of hand. Let me look here. Yes, this is human hand. Because this is at millimeter wave band, so that's why the size of the hand is very small. Okay, so this is hand. Okay, you can import the SolidWorks of, like here. Yes, you can download this hand, okay, from the internet, or like on this SolidWorks website. Okay, and you can download this hand and just need to import, okay, SolidWorks. In this way you can import the hand, okay, complete hand, and assign the properties of human body. Okay, so in simulation you can use this hand. Okay, or even it is very good to add in the paper. Okay,
How time it will take?
what?
How time for this simulation?
You mean how much time it will take for simulation?
Yes.
It depends on the compatibility of your computer or laptop. If you have a hard, I think 1 terahertz, then it will not take more time, like me. Oh, and RAM of 32 GB, then it simulate not more than 30 minutes. Okay, if you are only simulating, but if you are calculating the SAR values, then it may take more time. Okay, maybe 1 or 2 hours. Okay, but in the normal computer, like if you have a 500 gigahertz hard disk and 8 GB or I think 12 GB RAM, then maybe it will take half a day or maybe 3 to 4 hours.
Just for the hand, and if you have all human body.
uh, Full human body are not able to simulate even in high computers. Okay, for high computers it may take 1 day or 2 day simulation.
Okay. And I want to ask you about about acceleration option in sweep. Can you explain me about it?
Can you repeat your question about what?
I want you to explain me about acceleration in part sweep.
Acceleration. Can you write? I did not understand.
Yes, like that, and make new parameters like you want to.
Yes, first for this one, suppose you have this one.
Yes,
and
there was acceleration option in the right hand.
This
the
one.
Right side, yes. Yes. Can you explain me how to accelerate the simulation?
I where you are using this one? I think I did not use this one before. Okay, maybe I will check it one. Okay, and I will let you know. Okay.
Okay. Yes, please. Maybe it will help for simulation time. Reduce the simulation time.
Maybe I'd never use this one. Okay, because I use some other computer. I do not use this laptop. Okay, because in this laptop it takes time, but in my the computer of the university, it is a supercomputer and it is very fast.
It will also depend on the mesh sizes, but it will affect the frequency.
Yes, if you are simulating at a very high frequency, suppose if I am doing simulation at lower frequency band like at 2.45 gigahertz, then it do not take much time. But I am simulating this hand on at millimeter wave band or at terahertz, then it may take more time. Okay, because the mesh size, you have to increase the mesh size at the higher frequency bands. Okay.
Mr. Ahmed, for the computers in your university, what is their requirement?
About what you mean?
About computers in your university.
It has a
About
1
the
terahertz.
CPU.
Yes, it has 1 terahertz. I think. Wait a minute. I
1 gigahertz.
Wait a minute. I write here the specification. Somebody asked me the specification. I wrote here.
Mostly they give us like a 16 GB RAM and 1 terahertz, 1 terabytes hard disk, something like that, and including SSD also.
Yes, mine has 1 terabyte hard disk and for the RAM, it is 32 GB.
And about CPU?
For the CPU, I'm not sure, but I will show you here because I just settled my computer for 2 days ago. Okay, I wrote this specification here. Wait a minute. So this is the specification of my computer. Okay, this one.
Okay. How much RAM?
RAM, yes, my RAM is 64 GB.
Okay. That's nice. The Terahertz you said maybe 32 is okay also, yeah?
What?
32 for the RAM.
Yes, 32 is also okay. For my laptop, it is 8 GB RAM.
I have the 32 actually.
Yes, actually, just if you have a high RAM, then it helps you to do simulation very fast. Okay.
Yes,
I
yes.
have 8 GB RAM in my laptop. It takes much time in simulation, but in computer, it is very quick.
I use a desktop. Desktop computer actually is better than
Yes,
laptop.
yes, I have experienced a lot of this one. I was using at very first time I used the laptop, and the laptop was discarded because of many simulation, and then I used the desktop, and it was very fast in the desktop. Okay, but again I am when I moved to Spain, then I used the laptop.
Only for simulation running actually I use it. It's better, yeah.
Yes, desktop are very
But I
successful.
think there was laptops like workstations.
Yes, as Mr. Ihab has.
Yes.
They have super laptop. Okay, so do you have any other question? And tomorrow we are going to study human body antennas. Okay, and I will download some papers on terahertz so that you will have some knowledge on terahertz. Okay, and then we can study and decide. Okay, for tomorrow I will work. We will study on human body antennas. It is a very interesting topic. Okay, and also on implantable antenna, and I will explain all these type in explain in brief detail. Okay, because these are very interesting topic, and I like you work on these type of antennas. Okay, this was the simple antennas, flexible antennas, and wideband are nothing. The main topic will start from tomorrow. Okay, on human body antennas and implantable and dielectric resonator MIMO. These are very interesting topics. Okay.
Also, بالنسبة للسولوج you can prepare for us a 5 for tomorrow, including the phantoms and the human parts.
Yes.
And how we can use
Tomorrow you can ask me what you need. Okay, like if you need a human body, I will explain each and everything tomorrow. Okay, how, because this is my laptop, and I will show you how you can run the simulation on human body even in your laptop. Okay, if you don't have a super computer or laptop. Okay,
how we can assign the properties of the hand or something
yes,
like any part. Yeah.
Yes, I will explain. Don't worry.
Thank you very much.
Okay, so you have any other question?
Yes, sir. I have one question, sir.
Yes.
Sir, actually, I'm a beginner in antenna designing in this domain, sir. So I want to get some fundamental knowledge from theoretical point of view, from theory. Like, so can you recommend? Like, I know Balinese book is very famous.
Yes.
So can you recommend video lectures of certain good professors so that I
Yes,
can just follow?
I know some professors. I will share the YouTube channel. They are very interesting, and they explain very well. And in this way, you can have theoretical knowledge. Okay.
Sir, thank you, sir.
Okay. Any other question, please?
Sir, Balinese video lectures are available on YouTube. Like, sir, I didn't find Balinese.
I suggest you. There is a one, I think, Indian professor. The name of the channel is Engineering Funda. Okay, you can visit that channel, and you will find every lecture on RF and microwave and antennas. Okay, on that YouTube channel. Engineering Funda.
Okay. Please, will you share it on the WhatsApp group or?
Yes. I will share through WhatsApp. Also, I will share by email. Okay, don't worry.
Okay. Thank you.
So tomorrow when we study the human body antennas, then I will share more files with you. Okay, to run the human hand or to run the human body inside CST. Okay, I will share a folder. Okay, or also by email. Okay, so that you can be able to, because in this way, if you import the human body model, it will not simulate here. Okay, but if you have to do some steps to make your antenna workable. Okay, or to simulate at human body tissues.
I want to ask you, there is also a part about the human teeth or jaw.
What? Can you repeat?
There is no a phantom about the human teeth or jaw, the jaw of the human.
I think
I think
if you know the properties of epsilon value, then you can create your own phantom. Okay.
because maybe 2 or 3 years I read I read a paper about the the effect of the mobile about the human jaw and teeth. It was written in the I think it is a magazine of the antenna dual propagation. I don't see any application for this or any other research. Only this paper.
Okay, when we import the human body model, and then you will find I think more than 30 or 50 or maybe more tissues of the human body. Okay, so then you can select whatever you need.
Please, thank you.
Yes.
Excuse me, Ahmed.
Yes, please.
During the analysis of antenna, sometime on a surface current, we are when we do analysis of surface current, we sometimes we increase the V by M scale. So, is there any threshold for that we can analyze the surface current? Do you have, if there is any CST file you can open and I will tell you.
I did not understand your last step. I did not. Is there any file about
Like,
what?
like, is there any threshold that to this after this value we can an analysis of the result of the antenna at that threshold?
Actually,
Like sometimes,
actually, it
sometimes
depends
we
on the
increase in
antenna. Yes.
yes,
Complete your question.
like sometimes we increase and again decreases and to show the analysis where is the current going and where is current density. So, is there any threshold for that scale?
There is no specific threshold because I told you it depends on the frequency band, it depends on the size of the antenna. Okay, it depends on the radiator you are using. Okay, if you because sometimes if you are using the same threshold for the other design, then it will not show you the same graph as the for the other one. Okay, so you have to vary your V by M scale. Okay, to check because sometimes the current is flowing very low. Okay, sometimes at very sometimes the current flows much. Okay, so it depends on the design. Okay, so according to design you have to vary the scale.
Because sometimes the paper, if we need to show the surface current, so sometimes the papers they are showing the more current, more VIM scale is sometimes low, so that's why I'm
Yes,
asking.
just to make more visible in the paper. Okay, because if they are using like a low surface current, then how can reviewers be able to see the surface current? That's why they increase to show the current density. Okay, that's why.
Thank you.
Mr. Flip, do you have any question?
Yes, yes. I wanted to ask on the the crumbling. Like sometimes you want to, it's not just bending the antenna in maybe the X and Y axis, but maybe crumbling the antenna. I don't know if that feature can also be made possible.
Yes, actually, at first when I simulate the or bend the antenna, it gives some errors like maybe because of the mesh size or maybe because of the port. Because as I told you, when you bend the antenna, then you should no need to use dual sided bending. Okay, because if you bend from this side, then the port will not connect and then it will give you errors that your port is not connected with the design. Okay, so you need to make sure where you are some people like how they do mistakes. Okay, so let me show you here. Like I have this antenna. Okay, and some people assign or align WCS at the center of the substrate. Okay, so maybe you have done in the center of the substrate, so you need to do depending you need to align your WCS at the corner of lower bottom side of this substrate. Okay, did you try it with the bottom side of the substrate?
No, no, no. But what I wanted to know actually was in some cases when the antenna is being implemented, it's not only bending, but it may actually crash like it crumples, it folds into different kinds of shape, not only bending in a Y or X axis. So the bending is not uniform. It bends in different kinds of shapes. So that's what I'm trying to ask, that is it possible to also simulate that kind of bending effects in terms of like different kinds of fonts?
Yes, if you suppose if you want to blend or bend your antenna according to the like muscle tissue, or like you want to bend the antenna on a smart hand watch, okay, then you need to create a shape here or be behind the antenna, and then you will I think use some other tools like bend layer stack up, okay, then it will fully bend your antenna on the surface of the watch or like muscle tissue, okay.
Okay, okay, all right.
But in that most of the cases your antenna is not fully connected with the tissue, or like because your antenna is flexible and it has some distance like of 2 millimeter or sometimes 5 millimeter from the tissues, okay, or some other things.
Yeah, yeah, yeah. That's true.
Okay, any other question, so that we can end the meeting, and from tomorrow we will start, okay, on the other types of the antenna, and we will try to complete the types of the antenna as soon as possible, and so that we can start on the writing, okay, because writing is also very important thing in this course. So if you don't have any question, we can end the meeting, okay.
Mr. Sarosh, I want to ask about how to calculate the receive signal by the antenna, the data received.
There is a lot of distortion from your side. You mean you are asking about the power, received power, or what?
Yes, from the other antenna. Maybe if have two antenna or three antenna, I want to calculate the receiver from the one antenna to another. How much to receive data, or how much S11 or S21 or one or S12. How to calculate it? Is there any option in the CST?
Yes, I think it is available. For that you need to use two antennas, okay, in front of each other, okay. Like I have two antenna, okay, now okay. I need to You need to rotate, I mean keep the radiator in front of each other, like you need to rotate this design first, okay. Let me rotate this design. Okay, so you need to keep your antennas like this, okay, in front of each other, okay. Or maybe I think there is an option here in the result template, okay. In the I think S parameters, there is an option. I need to find it first, okay. In this case you have two antennas, so maybe it will be for, let me check here. You can calculate the event time delay, okay, and for the far field analysis,
What the result?
what?
Solution. For what the result? They can calculate the fidelity factor and everything.
Yes.
And also,
yes,
you can see the signal. If you go to the excitation signal, you can see the received signal, but you need to run the simulation. It will not appear.
yes, yes, you can find. Actually, this portion is basically for circularly polarized or MIMO or antennas, okay. Or many, you can calculate many things here, okay, whatever in front of you.
And also sometimes you need to write equation also to
Yes, yes, because all types of results are not available in this, so for that you need to use some MATLAB coding, okay, to calculate that things you need, okay.
Also, for the time delay, you need to assign. You need to have two ports to assign the time delay.
Yes, yes. We need to find it first. Okay, maybe I did not.
I think for 1D, I think. If you got 1D, because long time ago I don't work in.
Yes, I did not use for a long time, or maybe here.
1D general, I think you can find the time delay and Fourier transform, all these things you can use it.
Yes, you can use this.
Yes. You have many things here. BSD, which I showed you yesterday, I use this one.
So you can yes, you can guide to SAF full Sapti, okay, or in the group, okay.
But you need to run first, because you need to select
yes,
the signal from the phone.
For sure, we need in order to use this result template, you first need to simulate this design.
I think there is another option, brother. Sorry, but I don't use it before. I think there is a maybe field monitor, yes, for a distance, I think, or the I think the far field probe or something like this. Field probe. I saw before, maybe 5 years ago in a paper. They're using the field probe.
Yes, actually I told you in order to use the other like post processing, you need, if you want to use result template, you need to first simulate your antenna, okay, and by calling all these things, okay, like click on this, click apply, okay, click on the surface current density and other things, okay, then you will find more options in the result template, okay, and then you need to find here, okay.
From 0 to 1D, 0 to 1.
And, yes.
And their equation.
What?
Freeze equal.
Can you repeat your question? Your voice is disrupting.
I mean, there has equations for freeze equations.
Yes, we can. I will find and I will send you. Okay, on WhatsApp.
To calculate the power.
Yes, there are some equations. You can use MATLAB coding for that. Okay.
Freeze equation.
Yes, yes. Okay, you can ask me on the WhatsApp. I will send you. I will find and send you the equations. Okay.
Thank you, Mr. Saurush.
Okay, so if we can stop the